Hi, welcome my dear students. Today's our topic is a new chapter, that is what sets, right? We are going to continue this chapter, sets, relations, functions. Okay, we are going to discuss totally in-depth level of this topic sets in IIT level. We are going to discuss this. Regarding this definition, my dear students, what do you mean by a set, right? A set is a well-defined collection of objects. A set is a well-defined, right? This is very, very important. Collection of objects. Collection of objects. See here, this is well defined. It carries more meaning and important meaning in this, of course. Now I will tell you, see, for example, set means, let us take some example. I am having here a marker, a book, a duster, a plug, another one, a carom board, and a chair, like that. These are all objects. Can we call that as a set mathematically? No. Now, what is the guarantee that I am going to have, suppose, okay, another thing, suppose some other object, suppose, okay, a fan is going to be included in our collection or not? We cannot say that, because they don't have any common property. I told that a plug and a blackboard and also a duster and a chair, I told. And what is the guarantee that I am going to have the next one? Okay, that cannot be. Okay, just a collection of objects is not a set. Just a collection of objects is not a set. Okay, a set is a well-defined collection of objects. That is more important, like that. Well-defined is because well-defined means they will have some common property, right? Okay, some common property. That means, what you mean by well-defined means they will have some common property. That means, okay, we are able to decide whether one particular object or element will be in that collection or not. We are able to easily say that. That is what you mean by well-definedness, right? Okay, for example, I am telling that set of all electrical gadgets, okay, set electrical instruments. Then if I say that, is it marker belongs to that collection? No. Okay, therefore, because a marker is not a electrical gadget, okay, or instrument, right? Therefore, we can say that this is not a, okay, that means in this sense, what we can say is set of all example. For example, as I told you here, set of all electrical instruments. Set A is equal to set of all electrical instruments, like this. Electrical instruments, so like this. Okay, where a marker does not belongs to set A, like this. Does not belongs to set A. That's why, because marker is a, okay, this is not an electrical device. That's why, okay, this is does not belongs to A, like that. Now, if I take that as another example, B equal to set of all human beings. Set of all human beings. The human beings means we know that they have this characteristic, human being. Set of all human beings. If I say that a frag will be belongs to this, or a pencil will belongs to this collection? No. Therefore, this is what you mean by well-definedness. Well-defined means they have some common property. Here, the common property is human beings. Like that, we can give plenty, infinite number of examples we can give. Here also, in first example, electrical instruments. This is what the common property. Now, if I take that my handkerchief, is it belongs to set A? No. Handkerchief is not belongs to the electrical instrument. Number 2, set of all human beings. Like that, we have different kinds of sets. We can give infinite number of examples, as I told you. Set C is equal to, now my dear students, set of all sports instruments, like this. Sports instruments, like this. I have given that now. Right? This is sports instruments means you know that they are all having this common property, like that. Right? Suppose if I take a pillow. Is it pillow belongs to the sports instruments? No, not at all. Right? Like this. Understand? A chair. Is it a chair belongs to that? No. Like that. If set of all elements, if they satisfy some common property, then you will say that that collection is okay, well defined, then therefore a set is a well defined collection of objects. That is what very important. Now we are going to discuss how it is going to be represented, what are the different ways of representing. Okay, everything we will discuss very clearly. Now any set, now we have defined a set. Any set is generally denoted by capital letters, something like set A, we told that. Okay, set of all vowels, set of all, right? Vowels in English alphabets, something like this. A set is denoted by capital letters, right? B, set B equal to some other thing like this, something like A, B, C, D, like. Okay, they are denoted by, the set is denoted by capital letters. Very important, my dear students. Next, we have something like G, A, U, T, A, M, right? Something. G, A, U, T, M, like, because only one letter, the letters will not be repeated in this, of course. Okay, a set is denoted by capital letters, and also how it will be, the structure of a set is nothing but any set, as I have shown you here like this, right? Suppose set D, if I have, this is capital letter, and you will be opening the bracket here like this, flower brackets, and the elements inside of the set usually denoted by the small letters like that, small letters, okay, not capital letters. Here also small letters, G, A, U, T, M, like this, right? Small letters, something like A, B, C, D, E, like this, and they are separated by commas. This is the structure of defining of the set like that. Okay, now set E is equal to some 1, 2, 3, 4, 5, like any elements generally, right? We will open the flower bracket and close the flower bracket, and the elements are separated by commas. This is what the structure of the set like this, right? Now there are two ways of representing a set that we will now discuss. Now the description of a set, my dear students, there are two ways, standard ways of describing a set, description or describing of a set. These are, one is one is roster form. Okay, my dear student, this is roster form or tabular form like this, or tabular form like this, roster form or tabular form. Number two is set builder form like this, set builder form, right? Fine. One is roster form and another one is what? Set builder form. These are the two ways of representing or describing a set. Now let us clearly understand how this roster form and set builder form will be done like this. For example, roster form, I will take the first one. Roster form means each and every elements. For example, set A equal to, I am going to write A, E, I, O, U like this. Just a listing of all the elements. Listing of all the elements, what you call it as the tabular form or roster form like this. Okay, you open the flower brackets and just list all the elements. Then you call that as, right? This is what you call it as roster form or tabular form like this, right? And the same thing we are going to write this in set builder form. How we are going to write set builder form is, set builder form means we are going to mention the property of those elements, right? All English alphabets, all English, okay, alphabets which are vowels like this, which are vowels. This is the property, all vowels, otherwise are all English alphabets which are vowels. This same thing also I can write, that is nothing but X, such that here X, okay, we don't know, we are just describing the property of that element of that set. X is nothing but anything, randomly, it is a variable. This symbol indicates that such that, okay, X such that X is a vowel. X is a vowel, right? That's all. See, like this also, these both carries the same meaning. and these three are same only. This is one thing is represented in set builder form by just mentioning the property of that set. Okay, these both are same, and this is nothing but roster form. Roster form means in the sense we just list all the elements like this. This is what you call roster form, and set builder form is these both we can take like this, right? My dear students, this is the very important thing, right? How to represent them in roster form and set builder form. And I am telling you, my dear students, as I mentioned that this example, roster form means just listing of all the elements, and set builder form means I told you that you just required to write the property of those elements. That is what you call the set builder form, right? Now let us take one more example, my dear students. Here, example 2. Let us write set B. Okay, we represented with the capital letters, and this equal to, I am going to take 1, 2, 3, 4, 5, 6, 7, 8, something like this. This is what the roster form or tabular form. Now the same thing we can write in set builder form. How I am going to write that? X such that x is lesser than or equal to 8, where x is a natural number. See how we written? X belongs to natural numbers. Belongs to means that element is belongs to that set, right? Does not belong. Here belongs to means, suppose if I say that okay, 5 belongs to B, that is true, because 5 is an element belongs to. This symbol is means that belongs in mathematics. Does not belongs to means 5 does not belongs to B, like that we will write. Okay, here 5, not 5, here I 10 does not belongs to B, because B is containing only the elements up to 8. Okay, 10 does not belongs to B. This is true, and this is also true, like this. Here you see set builder form, how we written x such that x lesser than or equal to 8 and x belongs to n. X is a natural number, right? Wonderful. Now see, we have here right in a set of one simple problem. Describe the following sets in, right? Yes. Describe the following sets in roster form, right? That is what we have here is set of all letters. First problem, set of all letters of mathematics, right? The first one we have here, we need to represent this in roster form or tabular form. That means what you are going to have like this, right? In roster form means, I told you that if any letter is repeated, we are going to take only once. That is nothing but, now if M is there, here M, A, here T, H, E. Now M is repeated. We will be taking only one time. Like T is already came. I, like next one is what? I. Like next C, S, like this. Right? This is what the roster form, and this is what the set builder form, like this. Now set of all vowels in English in the word equation you are having like this. So here it is E, Q, U, A, T, I, O, N. Like I think all these letters are different. That's why every letter is taken into consideration. Now this is set of all natural numbers less than 7. Okay, that means less than 7, 1, 2, 3, 4, 5, 6. These are the natural numbers, right? Less than 7. Like this we will be representing them. Now set of all squares of integers, that is 0. Okay, 0 square is 0, 1 square and minus 1 square, that is 1, 2 square, minus 2 square is 4, 3 square, minus 3 square is 9, 16, 25, so on, like this, right? My dear students, like this, they given in set builder form, we converted them into tabular form. Or if these are given as in tabular form or roster form, we may have converted this into set builder form like this, right, my dear students? Wonderful. Now let us proceed further, right? Next we are having very important thing, my dear students, that is what types of sets, right? Neatly write the notes in your classworks. Types of sets, like this. Wonderful. There are different types of sets we are having, that what we will be discussing like that. The first one is empty set. Okay, the first one is empty set or null set or void set, right? There are three names, different names for this, right? empty set or null set or void set. There are three different names for this definition. What is its definition means? The set does not contain any elements at all. What do you mean by this empty set means? A set consists of no elements is called an empty set or null set or void set, right? It does not contain any elements. That is what the definition of that set. Right, it is denoted generally by pi, the letter pi, like this, right? That is equal to, okay, like this. We open the bracket and close the bracket, but no elements within that, right? This is what the way how we are going to define a null set, right, or empty set. For example, let us take, right, many examples we can take like that. For example one I am going to take here such that set A is equal to x such that x square equal to minus 2, where x belongs to real numbers. Is it possible? A perfect square will ever be equal to minus 2? Never. That's why this is equal to empty set, like this. Okay. Another example, right? Okay, we can give plenty of examples like that, right? Now I will give one thing that x such that right, x belongs to natural numbers and 5 less than x less than 6. Between 5 and 6, do you find any natural numbers? No. That's why it is empty set, like this. Like this we can give plenty of examples now. Like example 3, we can do one more thing like that. Right, my dear students? Yeah. Set of all even prime numbers. See here, I am giving that x such that x is an even prime. Even prime greater than 5. Is there any even prime greater than 5? No. Therefore, this is an example of an empty set. Right? Like this, my dear students, we can give plenty of the examples for this one. This is what you call empty set. Empty set is a set which does not contain any elements at all. That is what you call it as an empty set. The next one we have is a singleton set, like singleton set. Right? This is what you have, singleton set. A set consists of only one element, single element. That is what you call it as a singleton set. I am repeating once again, my dear students, you can write clearly. A set contains only a single element, right? A set consists of single element, like consists of a single element is called a singleton set, right? Wonderful. Singleton set. Now we can give, for example, right, I am having set A is equal to only 1, like this. This is a singleton set, like this. B, I am having some letter small a. This is a singleton set. Suppose I written like this. Okay, an empty set is part of the set. This is also a singleton set because this itself is a element, member of that particular set. That's why we call that as a singleton set, right? It contains only one single element, Nana. Then you call it as a singleton set, right? Next, the third one what we have is finite set, my dear students. Finite set. A set consists of finite number of elements. A set consists of finite number of elements. You see, a set consists of finite number of elements, like finite number of elements is called a finite set. A set consists of finite number of elements is called a finite set, right? That means it is having some bound. The number of elements will be, okay, some finite. For example, if I say that all the days in a week, okay, that is the example of a finite set, like that. Example, set A is equal to all the days in a week. This is countable, right? This is what you call it as a countable. That's why it is a finite set. B, set B equal to all the days of a year. Like this. This is also a finite set, like C is equal to set of all right? We have here human beings in common, that is countable, right? Human beings in common, that is countable. Even set of all human beings in India, that is also a finite set like that, right, my dear students? Next we have infinite set, my dear students, infinite set. In that name itself, the meaning is there. What do you mean by infinite set? Okay, this is a set in which a set will contains infinite number of elements. It cannot be counted, no bound, for example, right? No bound, no upper bound you will be having here. For example, I will say that, set A is equal to set of all, in mathematical, set of all natural numbers. These natural numbers, right, are what? Total infinite number of natural numbers you are having mathematically. Next, x says that x is a number between 5 and 6, where x belongs to real numbers like this. X is a number between 5 and 6 and x belongs to real numbers. Between 5 and 6 you have, this is what you call the dense property of the real numbers, my dear students. Between 5 and 6, that means open interval 5, 6, you have infinite number of numbers, right? 5.1, 5.11, 5.12, 5.13, 5.14, like that you have infinite number of elements between that, right? Therefore, this is also an example of infinite set. Like that, set of all living creatures on this world, on this globe, those are infinite, because every time some microorganisms like bacteria, virus, everything, that was uncountable like that, right? Like this, this finite and infinite sets will be defined, right? Next, the fifth one, what we have is cardinal number of a set. Cardinal number of a set. Cardinal number of a set. Okay, my dear students, this is what we are having here. The next fifth one, cardinal number of a set. What do you mean by this cardinal number of a set? Means the number of elements which are present in one particular set is called cardinal number of the set. I am repeating once again for your writing in your classwork. The number of elements which are present in one particular set is called the cardinal number of a set. For example, you see, my dear students, A, I am having here 1, 2, 3, 4, 5, 6, some. This is one set. Now, it is denoted by n of A. N of A means number of elements those are present in set A. This is nothing but 6, I will say like this, right? 6, right? Fine here. That's the way. Okay. Cardinal number of a set means that is what the meaning of it, like the number of elements which are present in that set, you call it as a cardinal number of a set. Next, B is equal to set of all the letters, set of all letters in the word equation, like you have like this, right? Now n of b is equal to how many? 1, 2, 3, 4, 5, 6, 7, 8 letters are there. Totally n of b equal to 8, like this. Cardinal number of a set means number of elements are present in that particular set is called the cardinal number of a set, right? Next we have the sixth one, two important things. One is equivalent sets. Equivalent sets, right? Fine. Equivalent sets. What you mean by these equivalent sets means, suppose if number of elements of two particular sets are equal, then those sets are called equivalent sets. For example, if n of a is equal to n of b, right? If n of a equal to n of b, then a and b are called equivalent sets, like this. Equivalent sets, right? N of a equal to n of b. For example, I will explain you with equivalent. There is one more definition. We are having equal sets. There is a lot of difference between equal sets and equivalent sets, right? Here n of a equal to n of b, then a and b are called equivalent sets. For example, how we are going to do this, my dear students, you see here, right? N of a equal to n of b. For example, I am having A is equal to A, B, C. Okay, 3 elements. And set B equal to, I am having 10, 11, 12. Okay, here n of A is equal to what? 3. That is equal to n of B. N of B also 3. Now A and B, these both are called as equivalent sets. That elements may be different, but they are having same number of elements. Okay, that's why they are called as equivalent sets. Equivalent sets like this. Okay, n of A equal to n of B. That are 3. The elements whatever they may be, but the number of elements should be equal. That's why it is called as equivalent sets like this. Right? Wonderful. Next, what we are having is, right, we will take one more example, otherwise, right? Okay, set A, I am having here something like this. Okay, AEIOU, okay, like this. And set B, I am having something like, right, I am having something like X, Y, Z, 1, 2, like this, something. Okay, these are the elements. Now n of A is equal to 5. That is equal to n of B, like this. Therefore, these both are called as equivalent sets now. These both are called as equivalent sets because both having the same number of elements, which are 5, like this. Next, we have another important definition, equal sets. Like, next we have, as I told you, equal sets. It's a very, very important, right? Yeah. See here. Equal sets. When we will say two sets are equal sets means those two sets should have, first of all, same number of elements and same elements. I am repeating once again. Equal sets. When we will say two sets are equal sets means one thing. First condition is they have to be supposed to be equivalent sets. Equivalent sets means same number of elements, right? Number 2, same elements. Then you call those two sets as equivalent sets, right? Equivalent sets. Now, if we discuss that with an example, then you will understand very clearly, right? For example, I am taking here set A equal to 1, 2, 5, 6. Like this. Set B equal to 5, 6, 2, 1. However, the same elements you are having here, but the order may different. However, this is now what you call as A equal to B. We call this as A and B are now equivalent sets, right? A and B, what we call them as now equivalent sets, right? Now, see another example just we take here. For example, I am having set C is equal to 1, 2, 3 here. D is equal to ABC. Are they equal sets? No, they are not equal. Here C is not equal to D, but here n of C equal to n of D. That means they are equivalent sets. Okay, number of elements are same, that is 3, but they do not have same elements. That's why they are not equal sets. They are just C and D are equivalent sets. Here C and D are equivalent sets. Equivalent sets. Right? That is what the difference. Here A and B, A, B are equal sets. Like equal sets. That is the difference between equal sets and equivalent sets. Like, okay, equivalent sets means they will have same number of elements, right? The same elements. Now equal sets means the sets will have same number of elements and same elements. That is what you call it as equal sets, right, my dear students? This is what the nice definitions of equal sets and equivalent sets we have discussed. Still, we have some more in our next class. We are going to discuss, some other definitions like subset to superset to power set to union of two sets to intersection, difference of two sets. Okay, symmetric difference, complement of a set, some properties on sets and some results on cardinal numbers. These all we will discuss in tomorrow's class. By that the concepts will be over, then we will be doing different kinds of problems from our material, and I will give some other things also to you, my dear students. One more thing, by before 20th, you are required to pay your fees such that to avail the opportunity of 20%. 20th so is the last date. Avail this good opportunity. Okay, my dear students. Thank you very much.